6. So the rest of this chapter kind of takes a little turn, and it emphasizes more on functions, okay? So today we're going to do function operations. Function operations, we're going to have our basic 4 operations that we do. And we've done these with polynomials, so they won't seem too weird. But we're going to take 2 functions, and we're going to add them together, subtract functions, multiply, and divide. All right, here we go. First of all, you can add 2 functions. You can take f plus g. Oh, sorry, hold on. This is part A, operations. Sorry about that. Did you have to erase? F plus g of x. All right, that looks a little strange when you do f plus g of x. Well, it just means to take function f of x and add it to function g of x, okay? I'm going to give you the operations, and then at the end we'll do an example of each of them. There's only 4. All right, same thing with subtraction. If you have f minus g of x, you're going to take, in this order, of course, you're going to take f of x and subtract g of x. Okay, if it was g minus f, you would do it the other order, the other way. All right, then you're going to have multiplication. F times g of x is the same thing as f of x times g of x. Okay. And then finally, the last one, division. So we have f over g of x is the same thing as taking f of x over g of x, as long as g of x is not 0. So we're going to have to put a restriction on that. So those are your 4 operations, okay? So let's just do one of each. I'll give you number 1. I'll give you a function. I'll give you 2 functions. Let's say that f of x is equal to x squared minus 1, and g of x is equal to x plus 1. Okay. So we're going to do each of them. We're going to use these functions. Okay, the functions change all the time. I could change f, I could change g. But let's go ahead and start with f plus g of x. Okay, this is going to be really simple. The thing is, though, is that people will mess this up because this is what I'll do. I'll write down f of x, and then I'll put a plus in the middle, and I'll write down g of x. And you know what people accidentally do? They FOIL. I know. It's so sad. They FOIL that because they see 2 binomials close to each other, but there's a plus in the middle. We're not going to multiply. We're going to add. And so anything that can be added up, we're going to. X squared doesn't combine with anybody. I have a -1 and a +1. Those will cancel each other out. And then I have a plus x, and that's what my answer would be. So I take f of x and add it to g of x. You don't have to show much work at all in this. It's pretty basic. Okay, so then we'll do subtraction. Now, as you know, subtraction is harder than addition, right? I think you learned to add before you learned to subtract. So if we're going to subtract these 2 things, then we're going to take our function f and subtract function g. Now, the thing is that people do here on accident is they forget to distribute. They're like, oh, I'm going to subtract the x, but not the 1. No, if you're subtracting g of x, you have to subtract all of g of x, all the terms. If there's 3 or 4 or 5 terms, everybody gets subtracted from g of x, in g of x, okay? So then if you want to, if this bothers you with all these parentheses, you can get rid of them. You can write x squared minus 1 minus x minus 1 like that, and then combine your like terms if that helps you, okay? No problem with that. So this would be x squared minus x minus 2. You don't need to factor that or anything, just leave it as is. Yeah?
That f minus g, and then you have the x t, is that going to be in all problems, or are you just putting that just because?
Just because these were called f and g.
Sure.
Yeah, so it's just taking that function f minus that function g. Okay, now let's multiply them. F times g of x. Okay, this is when they're going to be right next to each other. So I have x squared minus 1 times x plus 1. Okay, now this is times. Now we finally get to FOIL. Okay, and I've had people on the quiz, you know, they'll FOIL every single problem. And then they like, no, that wasn't all multiply. One was add, one was subtract, one was multiply. Okay, so if they're right next to each other and there's nothing in the middle, yeah, we're going to FOIL these out. So here we go. X squared times x is x cubed. Outside gives me x squared. Inside is negative x. And then my last term is negative 1. Ooh, there you go. I know, we don't have to simplify because nobody goes together, right? There's no like terms. Okay, and then finally the last one of these is to take f divided by g of x. This one is sometimes the easiest and then sometimes it's the hardest one. Okay, so if we take f divided by g, that's going to be x squared minus 1 divided by x plus 1. Now, you don't start canceling things out, okay? That's not allowed. What you can do is you can use this and you can factor and then reduce, okay? You can only cancel out factors. Let me show you what I mean. If I have 2 plus 3 over 2, am I allowed to go like that? No. No. Definitely do not do that, okay? But if I have 2 times 3 over 2, I'm allowed to do that because they're factors. You're allowed to reduce. I just reduced that. So if I go over here and I remember, oh, hey, I love that unit on factoring. That's the difference of 2 perfect squares. Anybody feeling that? This is x plus 1, x minus 1. Yes. Yes, some of us see it, some of us don't. And then what happens is, look, we have common factors. I have an x plus 1 divided by an x plus 1. And so this would just equal x minus 1. That's tricky, huh? Okay. Now, sometimes, though, like let's say that f of x is 2x plus 1, and g of x is x plus 5. Okay? Let's call this number 2, by the way. I'm not going to go through all of our operations. You guys know how to add and subtract and multiply. You know how to FOIL. But let's think about this last one. F divided by g of x. Okay? F divided by g of x is to take f of x, which is 2x plus 1, and divide it by x plus 5. I can't do anything else to this problem. So sometimes these are the easiest problems where you just write one function over the other and you leave it. You leave it alone. Okay, that's the answer. You can't cancel out these x's. There's no common factors at all. Okay, they might ask you for the restriction though. Okay, there's one restriction on this. I'm allowed to have this function as long as x is not equal to what?
0.
Okay, when you say 0, you're on the right track. Negative 5. Because negative 5, yes, it's going to make the bottom 0. So you're thinking correctly when you say 0, because that's what usually people will say. It can't be 0, can't be 0. No, x plus 5 can't be 0. So x can't be negative 5. Okay? Do you see that? Yes. If you subtract 5 to the other side, x can't be negative 5. Not 0. 0 is okay. 0 gives us what? 1/5. 1/5 is all right. But what about negative 5? Negative 5 gives me negative 9 over 0. Is that okay? No. All right. That's the only tricky part about that part. Okay, now let's go on to part B. Now this is my favorite part of the day. I do have favorites, of course, like my children. Okay, so part B, that changes daily. Yesterday it was the big kid, today it's not. All right, so this is going to be composition of functions. Composition of functions. Now, did you ever see that movie, Inception?
Yes.
Yeah. Did you have to watch it a few times, or you got it? I had to watch it a few times. It was like dreams inside of dreams, and it's
yeah, and
yes.
there's that spinning top that's like, and it starts wobbling. Am I in a dream right now?
This is going to be like kind of like that. Not dreams inside, but it's going to be functions inside of other functions, okay? Yeah, it's going to be super fun. Yeah, I'll show it to you. Okay, if you have something that looks like this, and that's a circle. Fog. Mm-hmm. Okay? This is the same thing as writing it like this. And I'm going to tell you how you actually say this out loud. So here's the writing, and this is pronounced f of g of x. It's a function inside of another function. You see that? It's function g sitting inside of function f. It's very exciting. Yeah. No, but it's not too bad. Bye. Good luck at your game. All right. So here's how you're going to do this. You're going to do kind of two things. You're going to evaluate. I wish I was going with you.
Well, no, I would be going with her.
If you were a girl who played basketball?
No, she does stats.
Oh, stats.
For my team.
Oh, for your team. Okay. I'm sorry. I thought she played basketball. All right. You first evaluate g of x. Okay? You're going to evaluate that. You guys know how to evaluate, like, g of 5. You plug 5 in, and you get something out. Then you're going to take that output, okay, and you're going to do step 2. You're going to put that in, evaluate f of x. Now, it's a little confusing by me explaining it to you until I show you how, to do one, okay? These are really fun. These are going to be super easy for you, too, after a little bit. Yeah, they will. All right, number 3. Okay, I'm going to give you two functions. I'm going to say that f of x is x minus 2. And g of x is the function x squared. X squared, okay? So two functions, f of x and g of x. And we're going to do a few of these till you understand them. Okay? So the first one we're going to do is we're going to find f of g of 3. Okay? Write that down, f of g of 3. Now, you probably have a good understanding of how parentheses work in math. You always want to start from the inside, work your way out, right? You learned that at a very young age. You're going to do that here, too. So we're going to first start by finding out what g of 3 is. Hopefully you can do that. We learned that last semester, right? What is g of 3? G of 3 is 9. Perfect. You plug 3 into the function called g. Yeah. So there's two functions. There's function f, there's function g. Right now I'm trying to evaluate g of 3. So I plug in g of 3 and I get 9. And then you know what you do after that?
You plug 9 into f of x.
Yes. You're going to take that output number that you get, and now you're going to plug that into f of x, and so your answer will be 7. You do not get two answers on these. It's not 9 and 7. It's a way of getting there. Have you done these before?
Yeah.
Yeah? Yeah. So g of 3, x goes out, and 3 goes in, and then you square it, and you get 9. Then that answer that you get, see g of 3, what does that equal? It equals 9. So now you have to do f of 9, which is 7. It's like this. I'll draw a picture for you because you like these so much.
Yeah.
Okay, here is the function machine g of x. You're going to love this. Okay, here it is. It's called the squaring machine, right? It squares everything. So if I take a number like 3 and I pop it into this function machine, what pops out of it? 9. But then this is telling me, don't stop there. Go over here to the function machine called f of x. It's kind of uglier, isn't it? And f of x is the function machine that says to take your number and subtract 2. So then now 9's going in, and then it's popping out as 7. So your answer is this final finished product. It's like, remember your laundry? Your laundry goes into the washing machine, comes out wet, goes into the dryer, now you have your clothes. Someone said it was like food. It goes into your body, comes out, gets flushed down the toilet. I'm like, no. Let's stay with the... Yeah, that's nasty. Let's stay with stuff. Okay, here we go. Let's try another one. Let's do g of f of 8. G of f of 8, okay? Now, you don't have to show work. If you're going to get used to these, you're going to do them super fast in your head. G of f of 8, you have to start from the inside and evaluate f of 8 first. Take that number and then plug that into g. It's like a string of things until you finally get the correct answer. Does anyone think they know what the correct answer is?
36.
Yes.
Oh, we're still using the.
Yes. Yeah, we're still using these functions. Oh, I'm sorry. See, here's number 3, and then this was A, and this is B. They're still the same functions. Yeah, now you try it. Now you try it.
Wait,
Yes.
put it first.
Okay, so you start from the inside out.
Right, yeah.
So you take 8 and you plug that into f. So f of 8 is 8 minus 2. And then you take that and you plug that into g, and you get 36. And that's your answer. Now, I've had people over the years who will tell me the answers are 6 and 36. It's not true. There's one number answer to this. Okay, you tried this one. Let's do f of g of -4. F of g of -4. Now, if you don't like that notation, because it looks like fog, right? This is the same thing as doing this, okay? If you want to rewrite it, you can. It does see how it didn't change places? F, G, -4, F, G, -4, okay? It stays in the same order. You're going to take -4 and plug it into G, get your answer, plug it into F. You try it. Same functions up here, x minus 2 and x squared. Ooh, I get some of your ages, huh? No?
15.
14? No one's 14 in here?
No.
Oh, sorry. Thought you guys were like 12 and 14, no?
No, I'm like that way.
No? Mentally, some, true. Oh yeah, 14, what's that, like an 8th grader?
Yeah. Well, you turned 15 when you were a freshman.
Oh yeah, my nephew just turned 14, like Sunday. Okay. Yeah. He's very nice. Okay, so you plug it in. What'd you get, 14? Yeah. You get -4 and you square it. That makes positive 16. And then 16 minus 2 is 14. Okay, I'm going to throw out one more for you. One more of these, and then we got to get to the last part. Are you ready for this one? Okay. How about G of 3? Ooh. Okay. G of 3. It's okay to use the same function twice. That's okay. All right. G of 3. So try it. Think about it. Think it through. You got it? I'm waiting for the answer.
81.
81. There it is. Okay, let's see how they got that. Do this first. What's G of 3? Go to here. 3 squared is 9. Then, I'm not telling you to plug it back into F. We're ignoring F. We're going to go back into G and square 9. The answer is 81.
What's 81 squared?
Oh, a big number.
29.
I don't know my perfect squares up to 81. Okay, last part.
Be careful.
Now let's do this whole thing, but let's do it with algebra. Variables. Okay, last part. Now we're going to have functions within functions. So here we go. All right. What do we got? 4? Number 4. Okay, let's say that we're going to do 2 more. F of x is x plus 3. I'm changing f and g. And g of x is 2x. Okay. Now I could ask you to do, there's like an infinite. I could ask you to do like f of g of 5, g of f of -3. I could ask you to do numbers. I'm not going to ask you to do numbers this time. I'm going to ask you to do f of g of x, and then we're going to do g of f of x. Okay? So without numbers, No numbers this time. It's a little bit harder. Actually, it's a lot harder. So here's what you're going to do. Now think about what this means. This first one means that I'm going to place g of x inside of f, right? Okay. If I was going to ask you to evaluate f of 5, you take this x and you get rid of it and you would put 5 there, right? I compared it to like if I'm going off for the day, I'm sick or whatever, and we have a sub come in. Sub comes in, I leave, right? The sub comes in. We're not both there. We're not multiplied together and doing the same thing. This is what we're going to do. We're going to take g of x, which is 2x, and we're going to take this out and replace it. Okay? And so you get 2x plus 3. Not 2x squared. You're not multiplying them. This x is leaving, and this 2x is going in place of it. Now let's go the other way. The other way says to take f of x and put that into g of x. So I'm going to take this x plus 3. I'm taking this x and getting rid of it and replacing that with x plus 3 there. So I get 2, and instead of x, it's now x plus 3, which is 2x plus 6. That's a little tough, huh? It got a little quiet because everyone's like, what? Yeah, this is where that dreams within dreams happen. Or nightmares. Oh. I can't watch that Haunting Hill. No. Anyone watch that? F of x. I know I keep using f and g. This is just my favorite function names. Okay. F of x is x squared plus 1. And g of x is x plus 3. Okay, here we go. We're going to go and, evaluate both ways. So let's do f of g of x first. Now, a lot of people don't like this notation, this fog notation or goth. So if you don't like it, like I said, just rewrite it next to it so that you know that g of x is on the inside. Okay? So we're going to now take all of g of x. What does g of x equal? It's x plus 3, right? We're going to take this x plus 3, and we're going to take that out and replace it inside. You get that?
X
Yeah?
plus 4.
No. It's squared, though.
Oh,
Yeah, we do have to FOIL. So this is going to be x plus 3 squared plus 1. Like if I told you what's f of 5, you would do 5 squared plus 1, right? What's f of negative 3? Negative 3 squared plus 1. What's f of g of x? X plus 3 squared plus 1. You're replacing it. All right, and then you FOIL that out. Can you FOIL that out quickly? There's a little shortcut there. Do you know how to FOIL quickly like that or no?
no.
No? You need to write it out, like x plus 3 times itself. That's okay. So you square the first term. The middle term's going to be twice 3x. And then you square the last term. And then we've got to combine like terms. So plus 10. There you go. All right, let's go the other way. The other way's easier. The other way, let's see if you can get this. This is going to be g of f of x. G of f of x. So we're going to take, f of x and plug that into g of x. So take this. This f of x is right here. It's x squared plus 1. We're going into here and replacing that x with x squared plus 1 now. So that I get x squared plus 1 plus 3. See how it was x plus 3? I replaced that x with x squared plus 1. And then I combine like terms. This one's easier. X squared plus 4.
Huh?
Where? Did I lose ya? You take this blue one, this x squared plus 1, and you plug it in place of this x. So f of x is going into function g, becoming x squared plus 1 plus 3, which when you do that, x squared plus 1 plus 3, you get x squared plus 4.